Hello and welcome back to my class. Let's continue with the review we started yesterday. I'm still with the quadrilaterals. Okay. Find the measure of each numbered angle in the rhombus. Here I have a rhombus. I have this angle that measures to 27 degrees and I want to find the rest. 1, 2, 3, 4 and 5. So we know that one of the properties of the rhombus is that the diagonals bisect the two opposite angles. If this is my diagonal, then it cuts these two angles into halves. Also, these angles, they are congruent. So 5 is equal to 27, and 2 and 3 also are equal to 27. So the angle 2 is congruent with 3, congruent with 5, congruent to the given angle that is 27. So they are all measuring to 27. Okay, for 1 and 4, we can say that in this triangle here, the total of the angles is 180. So this angle is 180 minus 27 minus 27, which is 126. The same thing for the angle 4. That is the total of these angles, 180 minus 27 minus 27, which gives 126. Or directly you can say that since this is a rhombus, the opposite angles are congruent, this should be equal to 1. Alright? Okay, almost the same example. I have this angle is given to 70 and I'm asked to find 1, 2, 3, 4 and 5. Okay, 1, 2, 3 and 5, they are all congruent. Again, why? Because this diagonal is bisecting these two angles, plus these opposite angles are equal. So they are cut into halves and all of these halves are equal. Alright? From this side here, I have 70 plus the measurement of 1 plus the measurement of 2 is 180. Now since the measure of 1 and the measure of 2 are equal, then I can replace in my equation m2 by m1. So 2m1 plus 70 equals 280. I simplify this equation and m1 is 180 minus 70 divided by 2, which is 55. Okay, m1 is 55, then 2, 3 and 5 all are 55 degrees. Okay, now what about the angle 4? Since it's the opposite of 70 and the shape is a rhombus, and rhombus of course is a parallelogram, the opposite angle should be equal to this one, that is 70 degrees. Let's go to multiple choices question. A rectangle is a parallelogram. Yes, always. The rectangle is a parallelogram. Why? Because opposite angles of my rectangle are congruent, opposite sides are congruent, and diagonals bisect each other. So it has, or it heritates the properties for the parallelogram all the time. So this is always. B, a parallelogram is a rhombus. This is sometimes, not always. Alright? If it happens that the parallelogram has all sides congruent, then it is a rhombus. So this happens sometimes, not always. A square is a rhombus. It's always true. Why? Because all the sides of my square are congruent. A rhombus is a square. Sometimes. When the rhombus is a square, when its angles are 90 degrees. Only when they are 90 degrees. Otherwise, it's not a square. A rhombus is a rectangle. It is sometimes right when its angles again are 90 degrees. In fact, in this case, it's rectangle and a square at the same time. Okay. Number 18. PQRS is a rhombus with PQ equals to 7b minus 5. PQ is 7b minus 5 meters, and QR is 2b minus 0.5 meter. If S is the midpoint of RT, S is in the middle of RT, okay, what is the length of RT, this distance? Alright, can we use the properties for the rhombus to find that the length of RT is such? How? From the definition of the rhombus, we know that all the sides are equal. First, I need to find B. So I would say PQ equals to QR. PQ equals to QR. Okay. Then 7B minus 5 equals to 2B minus 0.5. Okay. And B is 0.9. From this, I found only B. I'm going to plug it back in one of these, either for PQ or for QR. Now, look, RT is equal to TS plus RS. Since it's in the middle, S is in the middle, then RT equals to 2RS. We are dealing with the rhombus, then RS is equal to QR equals to QP equals to PS. So RS equals to QR. What is my QR? It is 2B minus 0.5, which is 2 times the value of B, which is 0.9 minus 0.5. Okay, multiplied by 2 for the value of RT, then the total is 2.6. So the length of RT is double of the length of QR, which is 2.6. Now, find the value of X that makes each parallelogram the given type. Here I'm asked to find X such that this shape is a square. Now, I'm given only one angle that is 90 degrees. I'm not given the others. Okay. And I've given that this angle here is 13x plus 5.5 degrees. When this shape is going to be a square, remember the property of a square is that its diagonals are perpendicular. They make 90 degrees here. So 13x plus 5.5 equals to 90. Solve this equation, then x is 6.5. So when x is 6.5, my shape is a square. For this shape, we need to find the value for x also, so that this shape is a rhombus. Definition of a rhombus says that all sides are congruent. So 14 minus x is equal to 2x plus 5. Simple equation. Solve it and x is 3. So this shape is a rhombus whenever x is equal to 3. Remember, this is a summary for the shapes that we have studied so far. We have a big family that we call quadrilaterals, that are the shapes that have 4 sides. Okay, we have a subgroup here that's called parallelograms. Okay, that are shapes or quadrilaterals that have opposite sides congruent, 2 pairs of parallel sides. In the family of parallelograms, we have rhombus that has all 4 sides congruent. We have rectangles that says that 4 right angles. Now, between these two families, they married and they brought us this cute child here that is called a square. So it has 4 right angles and 4 congruent sides. Half of its properties from the rhombus and the other half from the rectangle. We have a trapezoid, okay, which is out of the family of the parallelogram. The trapezoid by definition is at least one pair of parallel sides, which are the bases of our trapezoid. Finally, you have kites, which is like out of this group totally, that has two distinct pairs of congruent sides. So these sides from here are congruent and another pair from the other side that are congruent. Let's take an example of the kite. In the kite IBCD, the measure of BAE is 28 degrees, BAE is 28 degrees, and BCE is 57 degrees. Find each measure. In one, I'm asked to find ABE. Now I'm going to use this triangle here. The sum of these three angles is equal to 90 degrees. Sorry, 180 degrees. This one should be 90 degrees because the properties of the kite say that the diagonals are perpendicular. So 180 minus 90 gives A plus B, or EAB plus ABE. So the measure of ABE plus the measure of BAE is 90. This is 180 minus 90 already. Okay. Now the measure of ABE plus the measure of BAE, it's given here as 28. So I'm going to solve for the measure of ABE, which is 90 minus 28, that is 62. Right? The second, I'm looking for CBE. Where is CBE? CBE. Now, what is CBE? In this triangle, I have BCE plus CBE plus BEC is 180. Now, we know that this is 90 degrees. So 180 minus 90 gives us EBC plus BCE. So BCE plus CBE is 90. BCE is 75 given here, plus CBE is 90. I'm going to solve for CBE, that is 90 minus 57, which is 33 degrees. Number 3, what is the measure of ABC? ABC, this total angle. Now, ABC is the angle ABE plus the angle EBC. Okay. ABE was found 62. CBE was found in part 2 as 33. So their sum is ABC, which is 62 plus 33, which is 95. Finally, ADC, without any calculation, we know that the opposite angles here in the kite, these two, are congruent. So the measure of the angle ADC is equal to the measure of the angle ABC. So ADC equals to ABC, 95. So ADC should be 95 degrees. Let's go to yes/no questions. Sorry, multiple choice question. Determine whether each of the following describes a kite or trapezoid. Select the correct answer from each lettered part. A. The shape has two distinct pairs of congruent consecutive sides. Which property is this for? It's for the kite. I put here the two shapes here for you to notice these properties. So it has two distinct pairs of congruent consecutive sides. QR are as congruent, QP and P as congruent. But this is not true for the trapezoid. So this one is for the kite. B. It has diagonals that are perpendicular. Okay, I cannot see perpendicular diagonals here. They are not. But for the kite, we said that the diagonals are perpendicular. They make 90 degrees here. C. Has at least one pair of parallel sides. At least one parallel sides, one pair of parallel sides. These are the bases for my trapezoid. And this is not true for the kite. So this C is for the trapezoid, not for the kite. D. It has exactly one pair of opposite angles that are congruent. One pair of opposite angles that are congruent. This is the property for the kite, not for the trapezoid. These opposite angles are not congruent. Finally, it has two pairs of base angle. That's obvious. I have the base for the trapezoid, not for the kite. So it has two pair of base angles. These are the two pairs of base angles. This is one pair of base angle, and this is one pair of base angles. We also dealt with the quadrilaterals from the plane of coordinates. Let's take this example. I have this quadrilateral here, and I want to show that this is a trapezoid. So the first thing you do is to remember the properties, or at least the definition of the trapezoid. What is the definition of trapezoid? It says it has at least, okay, one pair of parallel sides. So it looks like ML and GK are parallel, but this is not enough. I have to prove it. How can I prove that these two sides are parallel in the coordinate plane? I'm going to use what? The slope. I'm going to find the slope of LM, the slope of GK, compare them. If they are equal, then GK is parallel with ML. I have here the coordinates for GKLM, slope of GK. GK. How can I find the slope? It is the difference of y's divided by the difference of x's. 1 minus 3 divided by 4 minus 2, which is minus 1 over 3. The slope of LM, okay, it is 1 minus 0 divided by the x's, which is minus 4 minus 1. So minus 4 minus 1, and this is 1 over minus 3, which is minus 1 over 3. So here I have the slopes equal. So GK is parallel to LM. By definition, this quadrilateral is a trapezoid. Now, activity 5. Show that ABCD is a parallelogram. What is the definition for the parallelogram? I should prove that AB is parallel to DC and AD is parallel to BC. How again? By using the slope. So I'm going to find the slope for AB, BC, CD, and DA. Alright? The slope of AB, the difference of y is divided by difference of x's. 4 minus 2 divided by 1 minus 3 gives us 3 over 2. The same way, the slope of BC, it is minus 2. Slope of CD, again, counting by y's divided by x's, which is 3 over 2. DA or AD, the slope is minus 2. Now, compare the slopes for BC and DA. They are minus 2. So BC and DA are parallel. Also, AB and CD have the same slope. AB and CD, they are parallel. So by definition, this shape is a parallelogram. Okay, I wanted to move or tilt your head a little bit. Some exercise for your neck. I know you are staying a lot these days in your computers, maybe gaming, maybe doing something else. Don't forget to make some exercises time to time. Alright, show that QRST is a rectangle. What is the definition of the rectangle? It has 4 angles that are 90 degrees, right? How can I prove that? I need to prove that QR is perpendicular to RS, RS is perpendicular to ST, ST is perpendicular to TQ. Perpendicular means it makes 90 degrees angle. How can I do that? The rule says if two lines have the multiplication of their slopes equal to -1, then they are perpendicular. They make 90 degrees. So let's find the slopes first. Slope of ST, okay, the same way. Difference of y divided by difference of x's gives me 1/2. Now the slope for TQ is equal to the slope of RS. Try to make your calculations and check it. That's -2. Now, if I multiply the slope of QR and the slope of RS, okay, QR and ST, it's half, and RS is -2. Half times -2 gives me -1. Okay, now the same thing I'm going to do for ST and TQ. I multiply TQ's slope, that is -2, by the slope of ST, that is 1/2. The product gives me -1. So this angle is 90 degrees, the other one is 90 degrees. Okay, QRST is a rectangle because it is a quadrilateral with 4 right angles. Now move your head to the other side. I'm sure you're hearing your bones of your neck cracking a little bit. Now prove or disprove each statement about quadrilateral WXYZ determined by the points W, X, Y, and Z. Okay, I need to approve or disapprove these two statements. Let me start from the statement number 1. The diagonals W, X, Y, Z are perpendicular. The diagonals of the shape W, X, Y, Z are perpendicular. So first, I will have the slope of XZ and the slope of YW, which are the diagonals. I multiply them. That's what I did. WY, this is the slope, 3 minus 0 divided by 9 minus 0. Difference of y is by x's, which is 1/3. Now the slope of XZ, 0 minus 3 divided by 5 minus 4, that is -3/1. Now multiply these, 1/2 times -3 divided by 1, it gives me -1. So this tells what? This tells that these diagonals are perpendicular. So I proved this statement. Let's go to the next statement. It says WXYZ is a rhombus. What is the definition for rhombus? It says that all the sides are congruent, meaning they have all the same length. How can I prove or disapprove that? I need to check these distances and compare them. So I will start by the distance WX, okay. The difference of x's squared plus the difference of y's squared, which is equal to the square root of 25, that is 5. The same thing for xy, square root of difference of x's and y's gives me 5. Yz has a distance of 5. Zw has a distance of 5. Now all the distances, meaning all the lengths, are equal, so by definition this statement is true. Thank you so much for following this class. Continue with the review of the chapters that we have covered so far. We are preparing for your midterms. We don't know still how are they going to be given for you. Anyway, be prepared, and I will see you in the next session. Thank you.